All right, we're going to be working on our Chapter 9 exercises today. I have the document pulled down that describes the exercises, so let's go ahead and open that up. We're going to look at exercise 9.4 first, and the instructions on this one are implement a class called address. Address has a house number, a street, an optional apartment number, a city, a state, and a postal code. Define the constructor such that an object can be created in one of two ways, with an apartment number or without. Supply a print method that prints the address with the street on one line and the city, state, and postal code on the next line. Supply a method called comes before, which tests whether this address comes before other when compared by postal code. All right, so we'll talk about all these pieces as we go, but let's get the class file built for starters. And so the way that we do this, and this is kind of interesting because you can really kind of approach this in two different ways. I do have a new file loaded up here in my Spider IDE. So I'm going to go ahead and do a save as on this. And I'm going to probably need to do a little file and folder management here as well, because I don't think I have a Chapter 9 folder yet. So I do have my Spring 24 folder. Yep, I'm going to create a new folder for Unit 9, which is for Chapter 9. And then I'll save my program in here. I'm just going to call it exercise. Well, actually, hold on a second. We're going to call it what we need it to be called, which is going to be address. So we're being asked to create a class file. And so rather than name it the exercise, I'm going to call it by the class name that I'm going to put inside of it. This is kind of an interesting approach here, because so far we've not really worried about the file names a lot, but this is going to give you a little bit of a clue as to why we kind of do this. Now, when we define a class file, we are going to use a very simple keyword here to kind of get that going, and that is the class keyword. I'm going to put a little comment here at the top. And I'm going to throw in the keyword. So here's the keyword class. And then I want you to notice here, I'm starting this with a capital letter A, which is not a rule, but a convention in programming. And this extends across languages, by the way. So kind of the same way we have a convention in programming when we have a constant, name it all in uppercase letters, or an implied constant in Python's case. There's also the convention that when you create a class or a blueprint, that you use an uppercase letter. So that way, when you're looking at it in code, you go, there's an uppercase letter here. It must be a class, right? Some sort of object. And so that is a convention. Now, interestingly, I could create a class file with all its definitions, list it all here, and then write a program file underneath to run it. And that's doable. You can do that in most object-oriented languages. However, the more typical way to do it is you create a separate file that holds the class, and then you write a program that you want to run that imports the class and utilizes it, right? Therefore, freeing the main program body of the overhead of including all the definitions for everything inside the class or object. Now, what Python programmers often do is they'll build what we call the init function, and they put that on top. This is the constructor function. So I'm going to define it to begin with. Remember, double underscore init, and then another double underscore, then followed by a set of parentheses. The set of parentheses must always include as its first parameter the keyword self. Because when we're building a new object, what are we building? Well, we're building this object, itself. So we're pointing back to itself, and that's always got to be there. But then we were asked to throw in a bunch of parameters. Now, before I kind of move on to that, right? So we're going to actually have a colon here, and then we're going to build. But sometimes what happens, you notice how I have a little red X here, and I'm not sure about all the stuff yet, so I want to go back and look at the instructions and then start building. Python has a keyword called pass that you can throw in, so that if you're just kind of thinking about the stuff you're going to build, often what you do is you write down all the method names or function names, but you don't know what's in them yet. So you use the keyword past to say, don't look at this, move on to the next one. But you see how it makes the error go away temporarily. So I'm going to just throw that in temporarily to make the error go away. But then I'm going to copy in this series of comments here, right? And this is kind of standard like Python formatting for indicating what a function or a method, right? So when it's inside of a class, a function becomes technically called a method, interchangeably used though. But it tells us what it does. So in this case, the init method constructs an address with or without an apartment number. We're going to have all of these different parameters that we're going to throw in, right? You'll notice one of them is marked optional, but we'll have the house, the street, the apartment, the city, state, and postal code. Right? We'll column that. So now inside these parentheses here, what I'm going to do is I'm going to call house, street. This will be information that we're going to send into this. City, state, postal. And then I'm going to do apartment number at the end with an equal sign and a blank string, which makes this optional. So if I don't throw it an apartment number, it just throws a blank in there, right? That's what that code does. I could change the order of it, but wherever I do the building of this object, which is going to be in an external program, we have to make sure that the information is sent in the order specified here. Now, once we have those parameters coming in, I can start building each one of the data properties. And the convention in Python is to use the keyword self, right? So puts it back into itself. And then this isn't a rule here, but this is once again a convention that some Python programmers use, not all, by the way, but some, where they add an underscore and then the name of the data property. And then you're feeding in the external property, and you can see how that matches up with the one coming in, and then it gets stored in this one. Now, the reason some programmers, and I'm just kind of putting it out there, use the underscore in front of the word house, right? And that would be the house number, like 1, 2, 3, 4, is because it makes it really easy to identify when you're looking at the code of an object that it's an internal data field. It's an internal property versus if I did it like this. And so last night when I was coding with my other students, we did it without, right? Because really I'm finding that more programmers do it without, but it's considered, take it for what it's worth. It's considered better practice to do it this way. So I'm going to do it this way for most of our examples here today. Right. So that way we have a differentiation between what's coming in and the one that's stored internally. All right, we're going to do the same with all the other data fields. So I'm going to say self dot underscore street equals street, self dot underscore city equals city. And you just follow the pattern. State. You'll notice also that we're indented because this is the init function. So all of these belong to the constructor, if you want to call it that, or initialization function. And then we have the optional apartment, which I just want you to notice that I'm not listing it here, or should I? Right? Well, I probably should, right? But I'm not. I'm going to break the order on it. And it doesn't matter here with the order. The order only matters inside those parentheses above. Because when I think about it, it's like 1, 2, 3, 4, Elm Street, apartment 5 is the order I think about it in. So that's why I'm going to put it up here. Now, remember, if we don't send that piece of information, it's optional. Don't worry about it. I put it out here at the end because that way, if you omit it, all the other ones will work just fine. So that's the first of the internal methods. Now I'm coming back one indent level. I'm not going all the way to the margin. And now I'm going to create another function or method, which we were told to create, called um, print address. So this one will be responsible for simply printing the address. So I'm going to define this as print address, set of parentheses, which must include inside the keyword self. Now I could send information to this, or I might not need to. In this case, I don't think I need to, because all this one is going to do is take all the information that are in the data properties above and just put them back up on the screen. And all we have to do is format it so it looks good as an address, because those are all separate pieces of information. What we need is to make that information look more orderly. So I'm going to start with a print statement, and I'm going to include self dot underscore house. And I'm going to say comma self dot underscore street. So that's going to be the first line. So like 123 Elm Street is a good example. Then I'm going to run a little piece of code here. And I'm going to say if self dot underscore apartment does not equal, so exclamation equal blank, if there's something that was in there, in other words, then I'll do a print statement where I will output the apartment number, and I will say apartment number space and then a comma, and then we'll drop in the number. It'll only print if we put one in. Come back one indent here, and then we're going to put in the city, state, and postal code. And then we're going to arrange those, because like think about how you usually do city and state. It's like, you know, for example, Racine, comma, space, Wisconsin, space, postal code. Right? But I want that comma in there to make it look a little more formal. So I'm going to do a print command, and then I'm going to use some formatting characters here. So I'm going to do percent s comma percent, percent, find a percent here, s space percent s. In other words, it'll be city comma space state space postal code. And then if you remember how this wildcard thing works, outside the double quotes, you put in another percent sign, and then inside a set of parentheses, you list the variables that you're throwing in there in order as they appear. So the first one would be city. Then we'll do state. And then we'll do postal code. And you see how I'm kind of letting the IntelliSense do the typing for me here. And I suggest you guys kind of get into that habit as you code. Don't try to type everything. If the IntelliSense finds it fast enough where it can put it back up on the screen for you, and that's the highlighted choice in that extra box, you just press enter and drop it in. So that's the print address function. Now we need to write one more method. This is kind of a weird one, actually. It's kind of a weird one to explain, but basically, when they put together the postal code system in the United States, it's not accidental, right? So if you live out on the East Coast, your zip code probably starts with a 0 or a 1. So like if you're in New York City, I think it's like 1 something, something, something. And then if you look at the zip codes in California or Hawaii, they start with the number 9. So in other words, working from east to west, the postal codes get bigger going from right to left, right? And then they also have a system where if you are, let's say, in the southern part of the state, your zip code will be smaller than if you're in the northern part of the state. So if you're in like Racine, or is it the other way around? I'm trying to think about that. I think like, so for example, like here in Milwaukee, my zip code is 532, for example. That's how it starts. Where in Racine it's 534. So it actually goes the other way, it seems, right? So it's like smaller numbers at the top, larger numbers at the bottom. So there's a system for it. And this is why you get postal workers that can kind of memorize zip codes, because they're like, oh, Wisconsin, that's a 5 and it's down there. So it's probably a 5, there's a whole kind of thing to it. The whole point of this method, though, is to determine whether the zip code comes before the other. So we're just going to define this and we're going to call it comes before. I'm going to throw in the self-referring, and then we're going to throw in other. This is just going to be a variable we create that's going to grab the zip code of the other address, and then we're going to compare it. And so simply all we're going to return is whether or not the postal code of the current object is less than or comes before the other one. Now, this is really kind of interesting, because basically what we're going to do externally here is we're going to create 2 or 3 or 4 addresses as objects, and then we're going to feed them into this method, and say, okay, we'll take the one that you currently have and compare it to the other one, which one comes first, right? And it just built into the class. All right. Now, if you've gotten all this code in, do a Control S to save. If you try to run this, this will not execute. This is just simply a blueprint. It is not a program. It is the blueprint for building an object. So that we have the class definition, we have the constructor or initialization function, which sets up all the data fields. We have an internal method that prints the stuff to the screen. And then we have an internal method which does a comparison of zip codes between similar objects. Nothing to run though. Notice the file is named all lowercase address.py, and that's important that you label it with that. So now we're going to go ahead and create another new file here. And then this one, we're going to test the addresses. So what I'm going to do is I'm going to do a save as on this, and I'm just going to call it demo underscore address. So we're going to, or you can call it test address or whatever you want to do. That's fine. I'll zoom in a little bit here. All right. And we'll begin basically by doing an import of the other file. Now they're both in the same folder, right? That's how I created them. But we'll do that import so that the program that I'm about to build can see that external file. Otherwise, just by being in the same folder doesn't mean I can necessarily import it. So you have to use the syntax. So the syntax is actually kind of interesting, because I could just do import and then just say address, right? So that's a possibility. But what's more typical is that we'll say from the address file. So I call the file by name, no .py here though, just the first part of the name, exactly as the file is created. We're going to import which thing from it. And what we're going to import is the whole address class. So from that file called address, we're importing the address class. Now, what this does is it puts at our disposal all the code that's in that other file. And all I have to do is call it by name and it will work. Pretty interesting, right? So when we did like imports of like math functions to do like square root, for example, that's really what we're doing. We're finding a particular file in the Python libraries, and then we're importing a specific function, method, or class and its capabilities. So now we're going to build a couple of objects. So I'm going to build one called my house. And then I'm going to call the class and the constructor, right? So when I call the class and put the parentheses after it like this, now I have access to that. But the initialization function back here requires that I send this information. Self won't be sent because it refers to itself, but all the other stuff will be sent and in that order, right? So here, I'm going to type in the info in that order, but I'm going to actually provide it the info. So the house number, well, that's a number. So I could do like, for example, 1313 And then we have a street name. And then we'll have the city. Then we'll have the state, and I'll just use the 2-letter abbreviation on that. And the postal code. And okay, so the postal code could be a number, but I'm going to argue that it's probably better off being a string. But you can make it a number, it doesn't matter. And with this one, I'm not going to send in an apartment number because it's a house. Okay, so house number, the street, city, state, and postal code. Apartment is optional. I'm not including it. All right. Let's make another object called your place. Once again, calling the class and the constructor. And then I'm going to feed in different numbers. So let's go 1200 Elm Street. Kenosha, Wisconsin, and then zip code. Trying to think of like an actual zip code down there. I think that's an actual zip code down there. And then we'll also include an apartment number like this. That since that one's optional, it's at the end. But this one has it, so we're assuming it's like an apartment building, maybe, or an upper flat or something like that. All right, so let's go ahead and do a demo of printing the address. So just to kind of show you how this works is I've now created 2 objects. So I took that blueprint and I built 2 things. Each has its own data properties, but just to prove that those data properties stuck, I'm going to go ahead and say print. And I'll say my house address is. So I really don't need the space there. And then I'm going to call the object by name. I created has all those data properties attached to it. And then I'm going to call one of the methods inside of it. And you see how it comes up on the list. And I think this is kind of interesting. So the comes before thing that we created shows up on the list. It's reading it from the other file. And the print address comes up also. And that's the one I want. So I'm going to choose that one. And what this will do is it'll reach back over here. And this is all built into the house object I created. It will reach to that method and output the information with the internal data properties. So that's all I have to do to get it to print. I don't have to type all those lines of code, don't have to be typed. It's already built. I don't have to type it again. I just say print address and it just does it. Then I'm going to put, by the way, a blank line after it. So I'm just going to do a blank print. Let's run this and see if it works. There it is, and you can see bigger that it pulled in the correct address. So 1313 Mockingbird Lane, Racine, Wisconsin, 53403. Now let's try that with the other one. So let's do print. Your address is. And now we'll just say your place dot print address. I'll put the address on the screen and then another blank line. Let's run it. There you go. So now I have my house address and your house address. And notice how I printed out the apartment number. And now that I look at that, I could see that I could tweak this a little bit. I probably don't need that space there. All right, so there is an example of creating the 2 objects and then pulling a piece of information out and running a method from that object. Now we're going to do the comparison. I'm just going to do a little print statement here first that describes what we're doing. Does my zip code come before your zip code? So what this is going to do now is it's going to reach into this method, and notice this has a comparison operator, right? So it's going to see if the one number is higher or lower than the other number. And what it's going to do is do that comparison and either return true or false. And the syntax on this is a little interesting, though. I want you to watch how this kind of works. So we're going to do it in a print statement so we can see if it's true or false. But I'm going to say my house dot comes before, and then what I'm going to put inside the parentheses is that entire other object of your place. So taking that whole object and I'm sending it over there, extracting its postal code, comparing it to that postal code of my house, and then it's either going to return true or false. So let's figure out what it would be now. Is 53403 less than 53140? And then here's another weird thing. These are both strings. Is that still going to work? Yes, it will still work because strings also interpolate to numbers as they get converted. So let's run this. There you go. So it is false, right? So now if I flip these, if I did 53003 and ran it, it would flip it to true. So this is the first exercise, folks. Exercise 9.4. Precious here. All right, moving on to the next exercise, and try to remember which one it is. Exercise 9.5. So exercise 9.5 reads, implement a class soda can with methods get surface area and get volume. In the constructor, supply the height and radius of the can. All right. So the first thing that we have to do is build a soda can class. All right, so I'm going to jump back over to Spider here, make a new file. I'm going to do a save as, and I'm going to call it soda can with an underscore. Now, I am going to kind of do this in somewhat hurry up fashion so we can try to get all the exercises done. There'll be a bit of copy pasting going on, basically. So if you want to put comments in like this, you can, but I like to just explain what's going on. Because we are going to be working on basically geometric math, right? So we're going to be looking at the surface area of a cylinder, basically, and all that. We're going to have to like work with this value for mathematics called pi. I'm going to import that from the math library. So my class definition can do imports too. So from the math library, I'm going to import pi. Yeah, I could approximate it mathematically, but this will be more accurate. We're going to define our class, which we're going to call soda can. Notice all where it starts with an uppercase letter. We're going to define our initialization function, double underscore, both in front and behind. We'll include the self-referring variable, but then we're told to feed in the height and the radius. Okay. And then we'll follow the conventions that we have. We're going to say self underscore height equals the height. That in. Self dot underscore radius equals the radius being fed. I'm going to skip some of the annotations here in terms of defining all of the things, but you know, I want you to keep in mind that usually when you're building a class, it's not a bad idea to like indicate to other programmers that might follow you what each method does and label it with all the parameters like this. I think it's very helpful, and I think it's kind of a nice courtesy. I'm just tight on time here, so I'm not going to do it in terms of coding efficiency. Our next function would be one that's going to get the surface area of this object. And You can Google the formula, by the way, and the formula is basically this. So if you like just Googled surface area of a cylinder, that's the formula. It's 2 times pi times the radius times height plus 2 times pi the radius squared, right? So then we just have to convert that to a formula. Here's what the formula looks like converted to Python. A second to type that in. I did kind of eliminate the spaces in there to make it fit on one line, by the way, so it's just easier to see. I'm going to start building the next function, which is the one that gets the volume of the cylinder. Once again, we send in the self-referring, and then the formula on that one, which you can also Google if you're curious, is pi r squared times h. Converted to Python syntax, it looks like this. Once again, I'll give you a second to type that in, but we need to hustle pretty much to get all these done. Once again, this is a non-executing program. We're just defining a class. We will import this class into our regular program to make it run. So what I'm going to do now is I'm going to go ahead and create a new file. Hopefully you guys got that copied in or real close. Remember, you can always go back to the video. All right, so here's my new file. I'm going to get rid of the comments at the top to save a little bit of space. But we're going to start with our import. We're going to say from soda can import soda can. So from that file called soda can, we're importing the class called soda can. We're going to build a couple of cans. We're going to say can 1 equals soda can. And then I need a height and a radius. And I think this is kind of interesting. This wasn't doing this with the previous program, but now like the engine must be catching up or something. But notice how it automatically is kind of creating these placeholders for the parameters I need to send in. So it recognizes I need a height and a radius. So I'm going to send in some numbers. How about 20 and 5? Yeah, what is this? Inches, millimeters, meters? I really don't know. Could be any of those. Let's create another can object. We'll call it can 2. Once again, a soda can. All right. And then let's send in the numbers 30 and 10. Now, what you could do, by the way, to verify that your math is correct, and I would recommend this, like if you go out to Google and say, for example, surface area of a cylinder, Google's pretty cool about this, right? So they show you the formula, right? And then you can enter in values. So if you put in like 30 and 10, it tells you what the result is. Kind of cool, actually. Also, like if you wanted the volume of a cylinder, they also have the same thing. So you could use this to check your answers, basically. All right, so we've created 2 objects. Now we want to basically get the surface area from one of the objects, get the volume from one of the objects, and put it back up on the screen. So I could do that all in one statement. I'm not going to, though. So I'm just going to create a variable called SA for surface area. And it'll be for can 1, I'm going to get the surface area. That was one of the functions that we created. So the numbers are already within the object. Now this is just going to return the result of the math, store it in a variable. We'll do the same thing with the volume. So we call can 1. And on this one, we're going to get the volume instead, and we'll store it there. Then we're just going to print it to the screen, and I have a couple of statements already prepared to print with, like this. So can 1 surface area is surface area. Can 1's volume is volume. Now we can do basically the same thing with the other can to prove that both of them worked. I'm just going to copy all that code, paste it in, and then just change the numbers. So I'm going to change it to can 2. that will pull the data from that object. Then I'm just changing the labeling here. Now, ideally, you would take all the numbers, pump them into like that Google page that I showed you just to verify that they're correct. I'm going to do a save as on my program because I have not done that yet, for shame, for shame. I'm just going to call it demo soda can. Save. I'm going to go ahead and hit the run button. And there's the answers. Now, are these the correct answers? Well, you have to verify that with Google. Basically, if you put in the numbers there, your numbers should be really close to what you're seeing on the Google website. All right, so that's the second program. I'm going to assume you guys are okay unless somebody like says otherwise, and I'm going to move on, folks. So let's move on to the next one. First, got to figure out which one the next one is. So we're going on to exercise 9.6. 9.6 says, implement a class car with the following properties. A car has a certain fuel efficiency measured in miles per gallon and a certain amount of fuel in the gas tank. The efficiency is specified in the constructor, so the MPG. The initial fuel level is 0. Supply a method called drive that simulates driving the car for a certain distance, reducing the fuel level in the tank, and methods get gas level to return the current fuel level, and then add gas to tank up. In other words, to add fuel back. So this would be some sample code that you could use. So for example, I would send the miles per gallon. I would add gas and specify the amount. I would drive for 100 miles, and then I would print the gas level. So this is an example of what we will do with this. But we have to start with building a car class file. So let's go over to Spider, new file, save as, and we're going to call this car with a lowercase c. Get rid of the comments here, zoom in a little, and let's create the class. Class car, capital C on that, right? That's the convention. We're going to define an init function, 2 underscores there, 2 underscores here. Include the self-referring variable. And the only thing that we're allowed or asked to send in is the fuel efficiency. You could call it MPG2, whatever you wish. Doesn't matter. All right. We'll set up the data properties. So the self-referring, and we'll have the fuel efficiency. Should spell that right. That's going to be equal to the fuel efficiency. Then we will also set a gas level. And this was implied, right? So here, I'm not sending this in, but it's going to start at 0. So instead of sending the value in, I'm just going to create self gas and then set it equal to 0. So whenever I create one of these, it starts with no gas in the tank. Next, we're going to define a function that allows us to add gas, because if we don't put gas in, we're not going anywhere, right? And then we can send in how much gas we're going to send in. So that's simply going to be a matter of taking that gas property and plus equaling or adding to it whatever amount we send in. That's all it's going to do. We're going to add it in. It attaches to the gas internal data property. Then we're going to define a function called drive, self-referring, and then how far we went. Right? And then what will happen is the gas level when we drive will get reduced by a certain amount, which is basically a formula that would be whatever the current level of the gas is, subtracting inside parentheses the distance divided by the fuel efficiency. Let's see, I'm waiting for the auto type there, so I don't have to type all that. So if if I take the distance divided by the fuel efficiency, right? So if I get, if I drive 100 miles and I get 20 miles to the gallon, I've used 5 gallons, and I subtract that from the tank. That's what this formula does. Oops. Right. Let's find the other function. We got one more left to do here. And this one will tell us what the gas level is. We're just going to call it get gas level. And then we're just going to use the self-referring. We don't need to send anything in to get that. And then we're just going to return very simply the self dot gas. So this is the car class. I'm saving it. Hopefully you guys are caught up. I'll give you 5 seconds here to type it in. And now we're going to go ahead and build the program that will run this. All right, so I'm going to create another new file. Doing a save as. And as you can guess, we're probably going to call this demo car, because that's been our pattern. You can call it whatever you want. It doesn't really matter. Demo underscore car. It's in the same folder. Let's blow away the comments here. And now let's build a program that kind of utilizes this. So the first thing we'll do is we will do our import. So we'll say from the car file, import the car class. Now let's add a few cars. All right, so like I'm going to do a couple here. So I'm going to say my hybrid. So I have a car that's a hybrid. I'm going to construct it and send it its efficiency of 50 miles to the gallon. I don't know if that's accurate or not, but some hybrids do get up to that. All right, so now it's created. It's got an efficiency of 50 miles per gallon, but I can't go anywhere with it because it has no gas, right? So now I'm going to say my hybrid add gas. How much gas? Well, let's say I can get 20 gallons in the tank. Then I'm going to say my hybrid drive 100 miles. And now I'm simply going to print out my hybrid, get gas level, and it'll tell me how much gas is left after that happens. Okay. You know what? I can run this. So let's run it and take a look. So if I have an MPG of 50 miles to the gallon, add 20 gallons of gas, drive 100 miles, I have 18 gallons left. Now, is that true? Right? Well, if I'm getting 50 miles to the gallon and I put in 20 gallons, 2 gallons were used to go 100 miles. So yeah, 18 is correct. That's how much I would have left. Now, I'm not sure if most hybrids get that much. I think most hybrids get more like 35 to the gallon. And actually, their tanks usually are not that big. They're more like 15-gallon tanks. Let's run it with those revised numbers. And so if it gets 35 to the gallon and 15 gallons were added, and then I drive 100 miles, is this what's left? And if you do the math on it, that it would be correct. So 12 point something gallons, a little over 12 gallons are left. Let's create a few more cars. And what I would ask that you do, and you can come up with whatever numbers you want. But I'm kind of goofy. I have a few different vehicles and I know what kind of gas mileage they get. And in fact, usually when I would drive down to the Racine campus, I would usually use my Volkswagen TDI, which is a diesel, right? And not a hybrid or anything, or electric, but this is the MPG it gets, which is pretty crazy. Part of it is because it's manual, part of it is because it's diesel. So it only holds 13 gallons. So that would be an interesting one to look at. And then I have a van, which is not fuel efficient at all, but it's big and it can haul stuff and tow stuff, right? And that only gets 15 miles to the gallon. It doesn't have a huge capacity. So just take a look at this. So like, in other words, you could create a few different vehicles, and notice that I'm creating them with names that match up with whatever it is, right? So like I have a hybrid, I have a TDI, and I have a van. So if I run this, you can see the results. So after driving 100 miles, how much gas do I have left in the tank? All right, so this is I think this was 9.6. I'm assuming you guys are all good. If not, please let me know and I'll pause the recording and stop. But we have one more exercise to do and I'd like to try to get through it. So let's go back and see which exercise that is. It's 9:10. Let's look up the instructions on that one. So here is 9:10. It says implement a voting machine class that can be used for simple election. Have methods to clear the machine state, to vote for Democrat, to vote for Republican, and to get the tallies for both parties. This is kind of an interesting one, somewhat timely, I guess. So let's go ahead and build first the voting machine class. So back over to our IDE here, creating a new file, doing a save as, and I'm calling it voting underscore machine. Coming in, more of the comments, and here we go. Here's my class definition. Capital V on this voting machine. Capital N, colon. We'll do our constructor function. Parens. We include the self-referring variable here. And now you got to think about like the instructions, right? If you read these carefully, has no indicator here that we need to send in any information. So when I create the voting machine, it just creates the voting machine. All right. All right. So what are the things, the data properties that we're keeping track of here? Well, they're pretty simple. When we create a new voting machine, we're going to have a vote count for the Democrats, the Democrat count. And when we create it, we're going to set it to 0. So when the first step of it is just set it to 0. And then we'll also have a Republican count, and we also set that to 0. If you wanted, you could add Green Party and Libertarian and all these others that will never get elected, but you know, it's certainly possible. But we're going to keep it simple. All right. Next, we're going to create a function to allow somebody to vote for Democrat. We include the self-referring. So every time somebody votes for a Democrat, what's going to happen? Well, the Democratic count will simply get a plus equals 1 vote. Right? Doesn't take a genius to figure out the next one. So if you vote Republican, if I can type it even, it's again self-referring. And we'll do the same thing with the Democrat, which is we're just going to do the Republican count, and that's going to plus equals 1. So we add 1. So vote Republican, vote Democrat just adds to the tally of the voting machine. Now, once you've been voting, then you need to kind of look at the results. So we'll have a function that simply gets the tallies of the votes. It's just going to look internally to get that information, right? And so it will very simply return the Democratic count and another piece of information, the Republican count. And notice it's being sent back as a tuple. Okay, now why would I do that? Right? Why would I? Because it's inside parentheses. If I put it inside square brackets, it would be a list. What's the difference between a tuple and a list? Well, a tuple is immutable. I cannot change the information coming out. So once the voting machine's created and you ask me what the vote count is, I can only send back the numbers and you can't change them, right? So that would be a good thing for a voting machine, right? So we avoid problems like we've had in the past, right? So then we also want to define a reset, which says like, hey, okay, well, new election, let's clear the votes and start again. So how would you do that? Well, I would do this. Just reset it back to 0. And then I get this thought. I'm like, well, yeah, this code is the same as this code. I don't know if you guys are seeing the logic here, but instead of having this code up here, what I could do is when we first build the object, instead of calling those out manually, I can just simply call self dot reset. This is kind of an interesting approach. So I start it, it runs an internal method which sets the counts to 0 instead of just having the redundant code call. Right? So this, I think, is a clever approach. So you don't basically need those lines. You're calling the reset, that's setting it to 0. So whether you're starting out fresh or you want to refresh thing. Okay. And Evan, I did see your message in the chat there. All right, so let's go ahead and save this. And what we're going to do next is we're going to build the demo program to run this. All right, so just give you a second to type this in if you're still scrambling to do it. All right, new file once again, save as. This one we're going to call, oh, I guess we could call it just demo vote. Or you could call it like election, I guess, too. Whatever, it doesn't matter. Right. What matters is that you're importing the stuff correctly. So let's start with that import. We're going to say from voting machine, import. Now, I'm waiting for the IntelliSense to kick in, but it's just not doing it. We're going to I finally, okay, there it is. So from the voting machine file, we're importing the voting machine class. Then we're going to create a new voting machine. I'm just going to call it VM. And what is that going to be? A voting machine with an empty constructor. That constructor, if you remember, does not require anything sent in. So just blank is okay, right? And what's happened now is it set up a Republican count and a Democrat count, both set to 0. So now we're ready to cast some votes. So I'm going to do this a couple of different times. So here's an example, and you can put these in any way you want, right? You load the machine up so anybody wins. So I'm going to cast 7 votes. And notice how we do that. We just call a voting machine, vote Democrat, vote Republican. Every time you call one of those, it adds 1 to the count. And then we very simply will put that back up on the screen like so. I'll give you guys a chance to type that in. And so basically what we're going to do is in this print statement, this is kind of an interesting print statement, we are using some string formatting here. So we're going to pull in the Democrats, format the digits, a few spaces, pull in the Republicans, a few digits, format those. And then we're populating it because there's 2 pieces of information here, right? But remember, the get tallies method returns a tuple. So it returns 2 pieces of information. That's why this works. So this returns 2 pieces of information. The first one is Democrat. The second one is Republican. That's why they're in that order. And so this will populate those 2 wildcards here. All right, I'm going to run this and show you that it works. So here comes the run. All right. So I had 1, 2, 3, 4 Democratic votes and 1, 2, 3 Republican votes. All right, well, let's say I want to vote again. So here's what I'm going to do. I'm going to put in a blank print command. I'm going to reset the voting machine so it clears everything back to 0. And then I'm going to put a message on the screen that says votes cleared. and then another blank line, and then I'll run another bunch of votes. So here's the other vote. In this one, there's more Republican votes than Democrat. And then we'll use the same print statement again. Right, that doesn't need to change. Let's run it again. There you go. So we ran one election, we cleared the votes, ran another election. We have a new total. And of course, you can do this again, right? So you don't have to do it just once or twice. You can keep doing it. And so I have one that, and you don't have to do this third one, by the way, just a couple like that is fine. But I have one, that might be like more like a real election. But if you can imagine, here's my code to reset. And then I just did a whole bunch of them to print it out again. I'm not even going to bother to count it. I'm going to let Python count it for me. And here it comes with all three of them. So, and that one, 10 votes for Democrats and 16 votes for Republican. But this is really simple code. But at the same time, think about like when you do actually go to vote. So I don't know how many of you have reached that point where you've been able to vote, but I would always encourage you to take your civic duty seriously and do it, right? Because it does matter. But you go to a voting machine and they have you fill out like these Scantron cards, and it goes in and they scan them. And then it figures out, well, did they vote for Republican or did they vote for Democrat or did they vote for this person or that person? And it's simple, very simple logic and code like this, right? It's just that it's optically read in that triggers the code. And then at the end of the day, they just run a little program, or it's probably a method inside of a program that gives the results, right? And then, of course, they have the physical copy that they can verify it with. So if they don't trust the output of the machine, they look at the cards and go, this is that, and this is that, and they can verify it. So just a very simple example here of doing the voting machine. So this completes all of the exercises. So I'm going to stop the video here. But I do have a request to kind of look back at something. For the people watching the video, don't forget to subscribe to the channel. And if you have questions, you can put them in the chat or email me directly. Thank you for watching.